Okay, so we can start the meeting. Yeah, welcome again for this third meeting about our wastewater treatment course. We are here in Hydrate. It's Federico Perotti, it is Sergio Galletta, and we have again Professor Marco Ravino from Politecnico di Torino of Turin that is online with us for this second meeting. I think that we are at the half duration of our course. We have ended the fourth unit, number 4. We started the fifth unit this morning. There is a good participation to the different activities. We have the forum that is very participated, very interesting, with many items that are raised and answered, and answered also by you. This is very interesting because there are many answers that come from you participants that gives energy and interest to the debate, and also in the participation of the different quiz questionnaires in every session, every unit. There is a good result in general, a good result in the course. So thank you for the participation and the exchange up to now. We are here in this meeting. We are exchanging particularly about the Unit 3 and Unit 4, and with Professor Ravina, that has also already answered to many of the questions emerged in the forum, and he will present also the following unit, number 5, about management of wastewater treatment plants, and the number 6 about sludge management.
Can I ask? This meeting is being recorded, so you can find it on the platform today or later tomorrow. Thank you.
Okay. So I start giving the floor to Marco for some contents exchange about what he emerged up to now, and then for the presentation of the second part, in the second part of the following unit's presentation. Please, Marco.
Okay, thank you, Federico and Sergio, and good morning or good afternoon or good evening to all of you. Let's briefly see some of the comments that you put on the forum, on the exchange forum, in the last weeks. What I saw by these comments is again as the same as told the last time, is that there is a high level of technical exchange. So many of you replied and commented on the comments or questions that were put on the forum, and in most cases my comments were just adding something more, because some of you already answered to these questions. I saw a lot of comments, as I said, more than the previous ones. So we will. I will briefly check some of these, recall some of these, and then you can ask some more questions if you like it. So I'm going to share my screen now and start from the last one of the question that was there. So we will last time we stopped at this point. So we we have one question. This is by Yasser. This is about the hygienization process and the use of sludge compost as in agriculture. This Yasser asked if someone could explain and supply a table shows standard parameter to the use sludge as compost. In this case, there were multiple replies by some participant, who I say thanks to them, because they provided very detailed standards for the use of dried sludge as in agriculture. And these limits or standards are the most important of these are the contents of fecal coliforms and pathogens that must respect a very low number. Usually the EPA from US sorry, standards are used, but also other than pathogens, particular care must be given to the content of metals such as arsenic, cadmium, copper, lead, or mercury. Also nickel, zinc, and other organic contaminants. So these replies that was given by Mohamed, these are very clear. You can check these answer on the forum, and also always keep in mind that for like this standard, as for other standards, there could be differences among different countries. So always check what is going on with about regulatory issues in your country. So then this was a general comment on the overall process. I will skip some of the comments or questions. There was a comment on quiz number 4, and we checked this question number 2. We checked the quiz, and we checked the solution, and we had clear that there is no mistakes in this quiz. So one of the answers is correct. Obviously, I cannot say which one, but I just say that there is the correct answers to this quiz. Okay, then there was a question about the determination of COD content in wastewater. The question was about the use of mercury sulfate, and basically some of you replied just by saying that mercury sulfate is used in the determination, so in the analysis of the COD, to mitigate the interference of chloride ions in the sample. So it is just related to the analysis procedure that is used in COD. This is the analytical procedure that is used in the laboratory. Also now there is some equipment that can use a measurement kit for the determination of the COD, so that all the organic matter is digested, and just check everything is correct. Okay, sorry. So the organic matter is digested, and also then there's a possibility of adding reagents and measure the COD very quickly with electronic devices, so that this is the procedure can be shortened. Also the consumption of chemical reagents. So I have nothing to add to this reply of Mohamed. Then the question number 13 went back to the topic of pH in wastewater. It was about how pH can affect the biological treatment process. Also, in this case, we have very, very complete answers of how pH could affect the biological process. So you can check the answers by Mohamed, and if I remember correctly, also by Amar. And you see very long, and also Joseph and Lemlem. Very complete answers about the role of pH. Overall, we can say that pH is affecting biological processes, so it can have an effect of slowing down biological processes, or also in some cases completely inhibit. There was also a question on which is the best stage to monitor and control. Depends. It is not possible to say it in a general way, but it depends on the process typology. But anyway, the control at the inlet of the biological treatment stage is crucial, because for the reasons that I just mentioned. About the methods for pH measurements, we have many possibilities. Very low cost systems or methods that, for example, the very known test strips that give a very rough indication of pH, but they are very cost effective. Also, there's the possibility of having very small and portable digital instruments, like, for example, the one we use in our university. These are easy to use, but and very precise, but they are actually quite costly to be bought. There's a very general question about biological treatments. Then the next one was about the use of constructed wetland as a nature-based solution. This is by Semachu. I hope the pronunciation is correct. Sorry if it is not. It is about how far a constructed wetland can clean the domestic wastewater. Will it be suitable for use for irrigation? This is not easy to reply, because overall the feasibility of reusing treated water for irrigation depends on different factors. First of all, on the initial water quality, the type of the process, and also the desired utilization of the water as well. So how you plan to use the treated water, for example, for crops or for vegetables that are eaten raw, or it must be maybe cooked. So some countries provide different standards depending on the different utilization of the wastewater for different purposes. What can I say is that well-designed and constructed wetlands have been shown to be efficient in cleaning domestic wastewater if this wastewater has no particular pollutants, so some pollutants that is not let's say standard pollutants. So depending on the configuration, constructed wetland can decrease the content of organic matter, also the content of nutrients, and also in some cases lowering the content of metals. What I always say is that the possibility to keep to be aware, to be careful in evaluating the possibility of reusing treated water, because of first of all, because of the content of pathogens. Constructed wetland have some filtering action with respect of pathogens, but in some cases it's very hard to reach the very low contents of pathogens, and this must be avoided because there's the risk of transmission of pathogens to the agricultural crops. There will be other about other comments and questions about constructed wetland, more next one. Okay, better. This was a better understanding of agricultural wastewater. Comments by Saba. Yes, in this case, there was a comments on the use of treated water for so how improve the water quality to achieve a good water quality for the use in agriculture. It seems that the reuse of water is something, and actually it is quite common. The reuse of water is something that is very important. So much of the effort should be done to increase the possibility of reusing water. In this case, the comments of Saba was talking about the content of sodium and salts. So that's in our country, excess amount of sodium and salt has been affecting the agricultural productivities. In this case, it seems that high content of sodium and salt could be due to the use of water that has been affected by salt intrusion. So there could be many possibilities for this reason, but usually this is the problem. So, and of course, water with a high salt or sodium content is not good for agricultural uses. In these cases, advanced filtering should be used, and also some method to lower the sodium content, and it is usually not that easy to achieve. Just one comment about the question of that was posed by Saba. She mentioned the trickling filters. Just want to make clear that trickling filters are devices and systems that are usually employed for for lowering the organic matter. So these filters are not good for the reduction of certain ions present that could be present in wastewater. Then we have still, I won't go again in this topic that we discussed a lot about the BOD, the equivalent inhabitant. I go for the next question, and this is a particular question about the hospital waste water. So in this case, we have also, this was a question that was posed by Enoch, and there was an answer by Amare, and I totally agree with what Amare wrote. So we are talking about hospital wastewater. So the main peculiarity of wastewater coming from hospital use is the possible content of persistent and harmful pollutants. In some cases, these are organic pollutants that cannot be removed easily from the wastewater. So the common approach here in Europe is the use of advanced chemical oxidation. Reducing these organics and oxidizing these organics. Also, in some cases, adsorption processes could be used. So, for example, it's not possible to achieve a very efficient results by applying just natural-based solution. In this case, I have some limits in achieving very high level of reduction. And the problem is that if these persistent organics are present, they can, if they are not removed, they will transfer to the receiving water bodies. So and they will increase their content overall in the environment. So okay. And this is a question about the production of sludge that is done during aeration. So during biological treatments, in particular, here we are talking about activated sludge system. Which the question is on which sludge quantities return to aeration tanks by aeration, and what is the contact time needed between wastewater and activated sludge. There was a quick reply on which I agree. And basically we can say that we cannot give a number on this sludge quantity and also on the contact time, but it all depends on the conditions of the incoming wastewater and on the process. So in general, the sludge production in conventional aeration tanks depend mainly on the BOD load and on the condition of the biomass. One parameter that is, I think, the most important is temperature. The higher the temperature, up to a certain limit, but the higher the temperature, and the higher will be the biomass activities. If, in general, if the sludge production is large as a result of rapid growth of the activated sludge, the residence time of the sludge will be low. Conversely, if very little growth of sludge is produced, the age of the sludge increases. So the size of the recirculation of the sludge recirculation will depend on this balance. So here I also reported some values, and we see a very wide range of values depending on the process and conditions. So the sludge age may vary from 0.5 days to up to 75 days in, for example, if we consider low growth rate systems. In general, in a conventional centralized plant in Europe, the SRT, so the residence time of the sludge, will be normally in the order of a few days. I also reported here a very interesting publication that is not that long, so it is quite synthetic, and it tells the basics of the biological treatment, of wastewater, and can give some additional useful information with about these aspects. Please see the link for this publication, and obviously if is free. Then, okay, with, number 20, we have another question about quizzes, and again, I won't say nothing about this because it is about one possible answers. So that is your task. So I won't say nothing about this quiz. Then we have a question about Yasser, about biogases and others gases produced by anaerobic digestion. The question is if there is any new technologies for making use of biogases produced in mega wastewater treatment plant. If yes, please inform me with simulation process or downstream. What can I say? Actually, I assume that mega wastewater treatment plants are very large wastewater treatment plants. I don't know if there's some particular definition maybe in your country about mega wastewater treatment plant, but basically we can say that we have two main solutions in Europe to make the use of the produced biogas. So in very large centralized wastewater treatment plants, there is a reactor for anaerobic digestion of the produced sludge. This anaerobic digestion produces biogas, which is a mixture of methane and CO2. Roughly, the biogas content is about we can say 60% of methane and 40% of CO2. Then there are also some additional components, such as the hydrogen sulfide, which is a gas that must be eliminated by this mixture. And the solution can be two once the biogas is produced. The first one is burning biogas directly into boilers or most probably into endothermic engines. This is to cogenerate both heat and electricity. And this has been the main solution up to some years ago. Now, in the last years, the most adopted solution is to clean the biogas, so eliminate all the CO2 and other gases by the biogas and producing biomethane. So that is pure methane. In the different application can be used for this, and when biomethane is produced, this can be injected into the national gas network, so natural gas coming from fossil origin, and this is additional biomethane that is produced by the water treatment, sludge treatment, so it has a sustainable content. In addition to this, and this is quite a new application, there is the biological methanation. So biological methanation works by mixing hydrogen and CO2. CO2 maybe they can be produced by the burning of fossil fuel or by any also biological activities. So by mixing H2 and CO2, there are a family of microorganisms that can produce methane. And in the same way, this methane can be injected into the national gas network. So we have a lot of CO2 to use for this process. We can use hydrogen when we have a surplus of energy from some other application, and then we transfer this surplus of energy into hydrogen, and then we can use this hydrogen to produce additional methane. This is a quite novel application. Then we have going on about this is about the Anamox process, which is a process, innovative process that is used for the reduction of nutrients. In general, Anamox is a very efficient and promising process, and because it avoids the double step of nitrification and denitrification that is commonly used in centralized wastewater treatment plants. This process is actually applied in several plants in Europe. We have one here in Italy that is on which we made studies. And what we saw during these studies is that this process is can be very efficient, but is very like the process management must be very precise. So the management of this process is challenging because a minimal change of conditions such as pH or water temperature could seriously affect this efficiency and avoid the correct removal of nutrients. So there was a first initial happiness in applying Anamox processes, but then there was in the last year there was like a little break in their application because of this difficulty in managing the process. Okay, this is a general recall of the different definitions. I won't get into this. And this is a comment in which I replied with another question. So what about, it was by Ragab, what about using effective microorganisms on wastewater treatment? And my question is, what do you mean for effective microorganisms? Because in biological process, different families or group of microorganisms is effective in doing something. For an example, the methanogenic bacteria are a family of microorganisms that can convert organic substrates into methane, so the specific family. So in this sense, as I wrote, specific bacteria families or group are effective in performing a specific task. So when biological treatment is going to start, it needs, let's say, a period of inertia, because first of all, the process condition must be maintained, and there must be a first initial selection of the microorganisms families that are able of doing of performing a certain tasks. This will be like a natural selection on these families of bacteria, and then when the selection is done after a certain period of inertia, the let's say steady state process will start, and the biological reactor will start working and as desired. Again, the question number 25 by Valerie she is asking if these values, the reported values on table 3, are standard regardless of the wastewater quality level. The answer is no, because these are just reference value. And this is something that I already said, but I'm still repeating it. The actual removal efficiency of a certain process might be affected by several factors. First of all, the raw wastewater quality. So I still recommend that the raw wastewater must be characterized in detail before proceeding with the design of every treatment process. And the same is valid also for the inflow in the plant, of course. Then this question by Yasser is about the ratio between BOD and COD. The ratio is not constant. Here the and can be BOD and COD ratio can be very variable. The more variable the ratio values, as the higher the COD to BOD ratio, and the greater of the percentage of slowly biodegradable and non-biodegradable material in the sample. Again, the time needed for treating wastewater will depend on process conditions, such as water inflow and water quality. I still recall this publication that shows more information about the biological treatments, and this I will quickly show you this figure, because this publication shows a scheme that you maybe know, that this is the total carbon content is divided into different specifications. So the total carbon content, total organic carbon, can be have a substantially not oxidizable fraction and a chemically oxidizable fraction. This chemically oxidizable fraction can be or not biologically degradable. So this is the first one is the chemical oxidizable, is the COD, and the biological degradable is the BOD. Then also, sorry, BOD can be divided into hard BOD, that is large molecules that might take hours to days to degrade, or soft BOD that are small molecules that are taken up directly by the microorganism. This is the very general, say, division of the organic carbon into the wastewater. So back to our questions. Still, I think we have still a couple of questions that are more recent. This is a question by Tamiru. How large, with respect to area and inflow, can we adopt the horizontal flow constructed wetland? This is determined by the dimensioning results performing using the equation that mentioned in the unit. If we consider the plane dimension, so we have an area, usually horizontal constructed wetland are rectangular shaped, if we consider the plane dimension. And so the ratio between the width and the length must be adequate to reduce the risk of an hydraulic short circuit that would lead to a reduction of the hydraulic residence time compared to the condition that were set during the design. So if the hydraulic retention time is lower, also the efficiency of the overall wetland will be lower. In general, L2V ratio, L2W, sorry, ratio range from 0.5 to 3. In the example that was given in the unit, for example, it was about 3. And in any case, the important aspect is that the width of the basin must be such that to ensure the uniform distribution of the effluent over the entire inlet section. So any hydraulic short circuits must be avoided. So water must be spread and transmitted all in the entire width of the constructed wetland. If in your calculation the overall width is very large, the solution is to design parallel wetlands, so more than one. Okay, still a couple of questions. One is a question about by Gloria about the most promising advancement or future direction for phytoremediation. As you must know, the ability of the plant, the efficiency of the plant is based on 3 factors: the filtering action of the roots, the oxygen transfer of the plants, and the capacity of absorbing a certain pollutant or certain kinds of pollutant, for example, metals. In general, I can say that the research on the plant activity is addressing all these 3 aspects, because these 3 aspects are are very important, and this is one of the strengths of the phytoremediation system, because it's not just the absorption capacity, but also the filtering and the capacity of transferring oxygen for the plant. So these are the main directions. And I think finally, still a couple of questions about biogas latrines. I can, this is something that is it was like placed in the forum some days ago, and I asked you to answer in my place, because the question is by Alfared, and it asks if is there any practical experience which has been functioning in an urban area for some hotels or institutions to use centralized biogas collection from biogas latrines. I have no practical cases in my experience. I think it's something that not easy to be applicable, but it's something that in principle can be done. So if you have any information about that, please reply to this question. And last question is still by Alphared is is on constructed wetland plant types. He asks some things about these plant types. If there's some plant that is not affected by specific weather conditions, and which is the great special knowledge on the construction of these systems, of the constructed wetland system, and something about intensive maintenance and what happened next. So I actually have some evidence that some of species have of plant species have less dependence of weather conditions. In general, these are related to the Helophytes group. And I just mentioned the one that are most used is, like, for example, Canna indica or Phragmites family or Juncus. These are plants that can also they always need water, but in some cases they can resist maybe in if there's a dry period that is not that long. The special knowledge in this system is, I would say, the correct hydraulic balance and design. And about maintenance, the first year is crucial, is the most important, because plants must grow and the system must start up, let's say, but also lately the maintenance and most of all the supervision of the system is very important, because the system tends to change the initial maybe perfect design, and also maybe the some like hydraulic shortcuts or something like that could appear. So these were the briefly some of the questions and comments. Very, I would say, very tough technical exchange. So a lot of topics too. So I have analyzed in the order that they appeared. So if you have some more question, or otherwise I will briefly present next two units.
So, Professor, let us see if there are some observation from the participants.
Okay. I forgot to say that there was also a mistake in the applicative example about the horizontal flow constructed wetland. Actually, we are going to correct the mistake, because there was a mistake in the equations. So thank you for letting us know.
In which unit, Marco? The number of the unit?
4.
4. Okay, thank you.
Anyone who wants to speak? To say something?
Write on the chat, please.
There is no intervention from the public for now.
Okay, so I can show something about the next two units.
Yes.
Yes, thank you. Bye.
So we are going to start. So this morning I just started unit 5. This is a very general unit, but very interesting too, that is based on the comparison and an analysis of two overall approaches, that is the centralized system versus decentralized system. And this is, I think, very interesting because depending on the context and on the process, and if we are close to our large urban areas or maybe rural areas, different approaches can be taken from under the perspective of treating wastewater. So these different approaches will be analyzed in terms of design criteria, operation and maintenance. That is something very important, in particular in developing countries, because if in particular every kind of system, but in particular centralized system, if not well maintained, will not keep their efficiency. So this is something that must be operational maintenance must be designed while designing the general process, and also some more consideration about monitoring energy consumption, and finally cost, so economic consideration. You will maybe come up at the end of the unit by with some useful criteria on when applying a certain approach, or maybe you will see that integrated approach between centralized or decentralized system will be a feasible solution with for your diciamo, say context. In this unit Y, we have a further reading related to energy efficiency and renewable energies. This is a very, like I would say, a very synthetic document in which all the possibilities are listed and mentioned. And then Unit 6, another very important aspect is what do we do with the sludge that is produced in wastewater treatment plants. Sludge is something that can be either a waste or a resource. So if sludge is used and treated correctly, this can be a very important resource. All the steps of the process that is are commonly taken for sludge treatment here are analyzed. So sludge thickening, the dewatering of the sludge, the hygienization, different methods of hygienization, drying, and then how to recover energy from sludge, so incineration or other kind of approaches. And also something about the possible uses or final uses of the treated sludge will be reported. Then the further reading is about recovery of phosphorus from sludge handling. Is something that is not easy to be applied, but is something that if applied can provide a very high value byproducts when recovering sludge. So this is the content of next 2 units. From my side, I think is all. We have still 3 minutes, so if you have some comments or a question, we are here.
Thank you very much, Marco. Thank you very much. And let us see if there are other eventual other questions for these last minutes. Then I remind also that the next and last meeting with Marco, with the Professor Marco, will be in 2 weeks' time, on the 24th of June, at the same time. And then we continue the exchange on the forum. I see, Marco, that you have already answered for the last question, so I will put the answer from the forum. Okay.
Okay.
When you send me. Okay.
Okay, fine.
Okay. If there is
no intervention, we greet you. We thank you for the attention. We hope that this is interesting, and we close the meeting. Okay. So
thank you.
See you next.
See you.
Time.
Bye. Thanks a lot.
Bye. Thank you very much.
Bye.
Good evening from the Philippines. Okay.
Thank you. Bye.
Bye, Yolanda.